Hi, my name is Bai Shun, and today we'll be going over FSAs and regular expressions for our class. So first, let's start with FSAs. So just an introduction, like an FSA will be um, a mathematical model of computation comprising of all four of the following. They have a finite number of states where exactly one is active at a given time, and then the transition rules to change the active state. And there's an initial state and one or more final states. And then this will make more sense later when I show you the diagram. And then we can draw an FSA by representing each state as a circle, then the final state as a double circle, and the starting state as the only state with an incoming arrow, and the transition rules are as labeled edges connecting the states. And when labels are assigned to states, they appear inside the circle representing the state. So, like on the contest, FSAs will usually be just parsing strings, like determining if a string is valid or not. So, this is an example of an FSA. So, this is the starting arrow. So, then it will come into here. So, in the above FSA, there are three states, A, B, and C. And the first one is A because the arrow goes into A. And the last one is C because no arrows exit from C. And then the only way to go from A to B is through this arrow. And so that means the only way to go from A to B is X. And then once in state B, you can either continue on to C or you can go to B again with another X. And then there can be an infinite number of X's as long as you go to C next. And then, yeah, C is the final state. So if the string being parsed is completed and the FSA is in state C, then it is accepted by FSA. Yeah, none of these FSAs are not on the elementary test. Okay. So in state C, any additional letter of Y will continue to be on state C. So you can add any additional number of Ys and the string will still be accepted by FSA. So here it says any of these strings can be accepted by FSA, right? Because for the initial state, we go into A and then we need an X to go to B. So we need at least one X. And then we can have any number of X's to remain in state B. And then we need a Y to go into the final state. So we need one or more Ys. So this one, all of these work because they all have one, at least one X and then at least one Y. Okay. So usually problems on ACSL with FSA will include translating an FSA to a regular expression, and a regular expression is just an algebraic representation of the diagrams or simplifying a regular expression, determining whether regular expressions or FSAs are equivalent, and determining whether strings are accepted by an FSA or a regular expression. So let's move on to some sample problems. So finding a simplified regular expression for the following FSA. So first we go in through this arrow, right? This is the starting point. So we go to this. And to get to the next state, we need a 0. So it'll be 0. And then to get into the next state, we need one or more ones. Or no, to get it, so we can have any number of ones here, right? Because if we wanted to go to the next state, we have to go through a 0. So to stay in this state, we have to go through a 1. So it can be 0 or more ones. So we 1 asterisk. Asterisk represents any number of ones. And then we need to go through a 0 to go through to the next state. And then we need to go to a 1 to get into the final state. So the regular expression for the following FSA will be 0, 1 asterisk, and then 0 and 1. Does everyone understand this? Okay, so let's continue. Um, So this is another problem, and again, we need to convert this FSA into a regular expression. So what we do is, again, we go through the whole diagram. So first we go through this arrow, right? And then we look to see if there's so we go to the next arrow to go to the next state. So we know we have to go through 1, 1. And then again, here is a arrow that keeps it in the same state. So this is an optional. It can be any number of times. So it'll be 0 asterisk. And then to get into the next state, we must only go through 1, 1. And then here we need to go through another one. But so because this is there's two options, we need to put like there's two separate paths we can take. We need it in that regular expression, we need to add an or sign, and an or is represented by a U. And then in the or sign, we put this side will be this expression, and what we put here will be this expression. So then what this one will be, let's first go through here. This one will need so basically what we want to look through is all the arrows that get to this point, because that's where they collide again. So for the first arrow, we know we have to go through another 1, so it'll be a 1 here. And then we know we must go through 1, 0. And then here it can be any number of 1s, right? Because it'll just go back to the same state. And then we need to go through another 1 to get to here. So it'll be another 1. So this expression is here. So this will be, so we have to go through here first. And once we reach here, we can have 2 points. So then we write both expressions with a or in the middle. And this expression will be this expression. So now we find the bottom expression. Which is again 1. And then again, we can go through any number of zeros and it will remain in the same state. So we do 0 asterisk. And then we have to go through a 1. So that will be the bottom path. So far what we have in our expression is this part is these arrows, and then we reach a fork in the road. So then we have to represent both pathways. So then we put this part here. And then we have an or, and then we have this part on the right side. And then now they meet again. So now we can just continue on writing the expression like normal. So we have, after the or, we have any number of zeros to remain in the same state. So it'll be a 0 asterisk. And then we have another 0 to get into the final mode, which is what we want to reach the final state. So does anyone have any questions about this problem? No? Okay. Let's continue. Okay, so the next problem is another conversion to regular expression. So we have so first we're gonna find, again, it's a very similar chart to the previous problem we had. So we're going to find this part, and then we're gonna use, there's a fork in the road. So for this one, we're gonna have to represent 2 rows with an or. So we're gonna have to do this one, and then we'll have a final part of the expression that will lead to the final state, which is what we want. So for the first part, we enter here and we must go through a 0 to reach the next state. So we have a 0. And then we have any number of 1s with this. So it'll be 1 asterisk. And then we have a 1. And then we have a fork in the road, so we write the parentheses, right? And the or sign. And then let's first go up the top half pathway. So we have 1 and then any number of 1s. and then 0, and any number of zeros, and then 0. We're going from this arrow down, and we can go through this any number of times, and then here, and then here, and then here is where they meet again. So we go until the 0. And then on the bottom pathway, we have 0, any number of zeros, a 1, any number of ones, a 0, and then a 1. And then now we've come back together. So now we go to the next state, or we can stay in the state first. So we have any number of ones. And to reach the final state, we have a 1. So that'll be the answer to this question. Are there any questions about this? No. Okay, then I'll continue. This is this is the same problem. So then I think that's it for FSAs. So now we'll move on to regular expressions, which is very similar to FSAs, but a algebraic representation. So I'll share my screen. So regular expressions are just the algebraic representation of FSAs. So the same concepts of FSAs of like going into different states will be similar to the one for regular expressions, but it's just a different notation. So let's continue. So we already went through this graph in the FSAs, and then so here are the rules for regular expressions. So a null string is also a regular expression. And then if we have string A in the input alphabet, then it's a regular expression. And if A and B are both regular expressions, then we can build strings by using the following rules of concatenation or union, which is A or B, like we did in the problems that we had before, or closure, which is again like the repeating ones. So repeating 0 or more times. So there's also order of precedence in regular expressions, which is first we have the clean star, which is the one we just went over, the one that can go an infinite number of times. And then we have concatenation and then union. And it's similar to regular algebra where parentheses can be used to group sub-expressions. Like for example, DCA clean star B generates strings DCB, DCAB, DCAAB, and so on, where DCA D parentheses C parentheses clean star B will generate like DB, DCAB, DCACAB, DCACACAB, and so on, which is basically meaning that the parentheses changed what we like can repeat. So this one just like isolates and puts the C and A together as one expression, and then we have to repeat CA instead of just repeating A from before. Okay, so then here are some identities. So A clean star parentheses clean star is this just the same as A clean star, and then AA clean star is the same as A clean star AA clean star union A null will be just the same as A clean star, and then A parentheses B union C is the same as AB parentheses AB union AC, and ABA clean star is the same as AB clean star A, and A union B parentheses clean star is the same as A clean star union B clean star clean star. And then A union B parentheses clean star is the same as A clean star B clean star again, and then A union B clean star can also be A clean star, and then BA clean star, clean star. And this will make more sense once we actually do a few practice problems. So these are just like the notation that we use in regular expressions. So you'll just have to memorize this in order to like do the problem. So this one represents alternatives. So it's like an or basically. So like this one can be gray or gray. And then we have the clean star, as we said before, it's just saying 0 or more of the element that we had before. And then the question mark indicates 0 or 1. So like the one we have here, we can have 0 or 1 used. So then the color with the question mark can represent color with an O or color with an OU. And the plus sign means 1 or more indicate occurrences of the preceding element, which is very similar to the clean star, except for we need 1 or more instead of 0 or more. And then the wild card means it can be A and then any other character, like here, it's any character. But it can only be one character. Like they said here, it's not A, B, B, B. Okay. And then a bracket expression matches a single character that is contained within the brackets. So for example, this means we have to do one bracket, that's one character, and between the brackets and 8, like we can use a dash to represent like all the numbers in between instead of writing everything out. So it's like a range. And then we also have the caret which in a bracket which represents a single character that is not contained within the brackets. So for example, this one will return any character that's not A, B, or C. And this will represent any character that's not a lowercase letter from A to Z. So regular expressions are case sensitive and literal characters and ranges can be mixed. And a parentheses, as we described above, like before, is a sub expression. So we can just use it to group this together. So we evaluate this first before we evaluate like the rest of it. It's like another being on its own. So are there any questions? No. Okay. So let's continue. So we already did this. So again, regular expressions and FSAs are intertwined together. So now this FSA should this problem should make more sense now that we've explained regular expressions because again, regular expressions are just the algebraic representation of a diagram basically. So they're like interchangeable. So next, let's try this problem. So which of the following strings are accepted by the following regular expression? So what does this expression mean? So this one means that we must have a 0 to start, and then we can have 0 or more zeros, and then we can have any number of ones, but then we must have a 1. And since there's a union, they're evaluating this one or this one. So first, yeah, this one we just went over. So we're gonna evaluate if they this expression accepts like any of these strings, and then we'll evaluate if it doesn't, it might be this one. So we have to evaluate basically two separate identities, and if one of them is accepted, then we can put it, that will be the answer. So we have for this one it's 0 and then any number of zeros, and then 1 and then any number of ones. So for this one we have 1 and then any number of ones and then any number of zeros and 0. So we have for this one, let's check A. A works because it is accepted by the first FSA because it has first a 0 and then all of these zeros are taken by the 0 asterisk, and then we have any number of ones and then we have a 1 behind it. So this one will be accepted. And then we have, let's check B. So we do not have a 0 to start with, so B does not work for the left side of the expression, but it might work for the right side. So let's check the right side. So we have a 1 first. Yes, that works. And then we have any number 1. So there's no 1s right behind that 1. So then we move on to 0. So we have a 0. That works. And then we have any number of zeros, and there's no more zeros behind. And since there's nothing left in that regular expression, this one doesn't work because none of these are following the regular expression. So B will not work. A works. And then let's check C. If C follows into the left side or the right side. So first let's evaluate the left side. It has to start with the 0, like we said before, and it doesn't. So this definitely does not satisfy the conditions of the left regular expression. So let's check the right side. So we have a 1 and then any number of 1s. So it'll be all of this, and then we have any number of zeros and a 0. So we must have a 0 at the end, and since there's no 0 at the end, this one is not accepted either. So then let's check D. So it's satisfying the left side so far because there is a 0 at the beginning and there's any number of zeros. So then we don't have any zeros behind that, so we just move on. So that any number of 1s and a 1, which is here, works. But then we have a 0 behind here, but there's nothing in this regular expression that asks for another 0 at the end. So this one will not work. But we can check the right side. It might work on the right side. So we first must start with a 1 on the right side, but since this one doesn't start with a 1, it won't work. So D doesn't work. And then next, let's check E. So let's check the left side first. And again, we need to start with the 0, but there's no 0 here, so it doesn't work. But for the right side, we can have a 1. So that works so far. And then any number of 1s, there's no 1s, but that's fine. And then any number of zeros that is 0. So this one does satisfy that because there is a 0 here. So for this problem, A and E are the ones that are accepted. Are there any questions? No? Okay. So then let's continue. Which of the following strings match this regular expression? So what this expression is saying is, again, remember the brackets represents, it can be any letter that is inside the expression in the bracket, and remember the dash represents all the letters in between. So this bracket is, what this part is saying is the expression can start with any number of letters that are in A through D, which is basically A, B, C, and D. So, and then we have any number of letters that are lowercase A, B, C, or D. And then we have, there must be only 1, 0 through 9. Like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 all can work. But there can only be 1 and only 1 because there's no asterisk at the end. So let's check which of the following strings are accepted. So we have, for the first one, we have an uppercase A, which will go into here. And then we have an uppercase B, which also goes into the first expression. And a C and a D, which all go into the first expression. So far the string is accepted. And then we can have 0 or more of lowercase a, b, c, and d. And since there's none, it's still accepted because, again, this clean star represents 0 or more. And then we go into the last, to go to the last phase, we need a final state. We need a number, a digit, and we do have that here. So the first string does work. And then let's check the next string. Similarly to the first string, it's lowercase letters A, B, C, D. So it doesn't go into the first one, but we don't need it to be accepted by the first one because, again, it is a clean star, so there's 0 or more of uppercase A, B, C, and D. So then all of this will be put into this expression, 0 or more of lowercase a, b, c, and d, And then we need a digit at the end. So this one works because we have a digit at the end. So 1 and 2 both work. For 3, we have 2 uppercase, which will go into the first part, and 2 lowercase, which are accepted by the second part. And then we have a digit, which is accepted by the third part. So number 3 also works. For number 4, we have an uppercase that will go into the first part. And then we have a lowercase, which will go into the second part. And next we either need another lowercase or a number. And here we have an uppercase. So this one is not accepted because we already went through the first one and the second one. So then we have an uppercase X, which will not be accepted because, again, we need something in between A and D. So number 5 is not accepted. Number 6, we have lowercase a and b. So we can skip the first part because, again, it is a clean start, so it can be 0 or more. And then it's accepted into the second part, but then we have an uppercase C and D that are not either lowercase or a number. So this one will not be accepted. And then the last one, we have all of these uppercase letters will be put into the first part of the expression. So that works. And then we have all of these lowercase that are in the second part of the expression, which work. And we have a digit. So number 7 works. So are there any questions about this question? This problem? No? Okay. Let's continue. Which of the following represent this regular expression? So let's go over what this one means. So again, the question mark represents 1, 0, or 1 of this. So there must be 0 or 1 i's following an uppercase H, and then a plus, unlike a star, is 1 or more. So there has to be 1 or more G's, and then 1 or more H's, and then it must end in something that is not in between A, B, so not A, B, or C, or E, or I, or O, or U. Because again, the caret represents not. So let's go through the strings. So for the first string, we have an H, which works, goes into the first state. And then we have 0 or 1 i's, so this one works. And then we have 1 or more G's, which works, and 1 or more H's, which works. And then we have a B, which is not accepted, right? Because we need the string to end in a letter that is not in A, B, C, or E, or I, or U, O, or U. So then 1 is not accepted. So number 2, we have an H, which works. And then we have 3 i's, which does not work, right? Because the question mark represents 0 or 1 i's. So then number 2 does not work. For number 3, we have an uppercase H, which works. And then we have 1, 0, or 1 i's, which works. And then we have 1 or more G's, which works. And 1 or more H's, which still works. And then we have an uppercase C, which is not any of these letters. So number 3, the third expression will be accepted by that regular expression. And then for the fourth string, we have an uppercase H, which works. And we have an I, which works, 0 or 1 i's. And then we do not have 1 or more G's. So number 4 does not work. For number 5, we have an uppercase H, which works. And we do have 0 or 1 i's. And then we have 1 or more G's and 1 or more H's, and then we have E. And again, E is inside of this, so it does not work, right? Because we want not that. So the 5th expression will not be accepted either. And then the 6th expression, we have an H, uppercase H, and then we have 0 or 1 i's, and then we have 1 or more G's and 1 or more H's, and D does not fall into A, B, C, E, I, O, or U. So the sixth expression works. And then we have the seventh expression, which is an uppercase G, which works. And then we have H, which works. And then we have 0 or 1 I's, again, matching the question mark. And then we have one or more G's. All of this could be swallowed into the G plus. And we have one or more H's. And then we have an uppercase X, which is not in A, B, C, E, I, O, or U. So then number 7 will also work. So for this problem, the strings 3, 6, and 7 are the ones that will be accepted by the regular expressions. Are there any questions about this problem? No. Okay. I want you guys to try this problem and see which ones will be accepted by the regular expression problem. I think the point represents a one or the other. Yeah, anything. Okay, so I see. There's okay. So let's go through this problem. In a while. Um, I think a wild card has to be a character. There has to be a character in between. Okay, so for this question, we have what this would means is we have any number of the characters uppercase A, C, S, or L, and then we have any number of characters that aren't. Oh, okay, then the wild card, I think it can be then 0. So then for this one, we have um any number of non A, E, I, O, or U lowercase digits. And then we must have a 2 and then a 1 and a wild card. So any character between 1 and 2, and then we must have a 2. So then we have uppercase A, which will fall into this one, and then we have lowercase b, which will fall into this one, and then we have a 2, and then we have a 1, goes here, and then we have any character between 1 and 2. So then I think following the definition of a wild card can be any character between 1 and 2, then we'll have this one will just have nothing in between 1 and 2. So then this 1, and then we have a 2. So this one should pass. I think, yeah, the wild card meaning can be anything. There can be nothing between the 1 and 2. Oh, in the chat they're saying an asterisk means 0 or more. So I'm assuming the wild card actually means there must be a character between 1 and 2 because there is a specific character at the dot, and no character isn't really a character, so then A would fail the test. Okay. If there, however, was a asterisk after the dot, then this string would pass the test because wild card means 0. I mean a star would mean 0 or more. So this one, I think it is A does not pass. The first string doesn't pass. So next we have ACSL uppercase 21. So this one will all go into here, which works. And then we have 0 of the non A, E, I, O, U characters. And then 2 will go here, and 1 will be here. And then we need another character after and a 2, which is obviously not here. So B also fails. And then we have the next string, which is the ACSL will go into this part of the expression. And then the 4 and the 4 are both non-A, E, I, O, U characters, which will go here. And then we have a 2 and a 1. And then we have a 2 and a 2. And I think that this one should work because it is any character between. But wait, I think this one, let me double check the explanations, the definitions back here. Because I remember they said wildcard matches any character. So yeah, then it can be any character between them. So this one will work. The 2, 1, 2, 2. Because the 2 is represented by the dot, and then we have another 2. So then C works. Okay, continuing. we have the next expression. Does the dot apply for all the digits before it? Yeah, I'm confused by your question. Okay, so let's continue. So for this one, we have no capital ACSL or L, but that's fine because the star represents 0 or more. So then we automatically go into this part of the expression. So C is not an A, E, I, O, or U, and M is not, P is not, T is not, R is not. So we have a 2, which goes here, and then we have a 1, which goes here. And then we need a something in between the 1 and 2, because again, this is a wild card. So I think that D will also fail. Okay. And then we have E, so the A will go into here. And then I see ahead that this one will fit into this expression. So then we know the 2 is not going to be this 2, but instead the 2 is going to be accepted into the non-A, E, I, O, U characters. So the 0 can also be accepted into that. So E will work. And then for the last problem, all of this goes into here. And then we have a 2 and a 1, which are accepted by this and this, but then we need another character to 2. So F will also fail. So the only one strings that will work that are accepted by this regular expression pattern are C and E. So are there any questions about this? I'm not sure if this class will be in the elementary contest. I think you can check that on the ACSL website. So then let's continue. Okay, so which of the following expressions are represented by this regular expression? Okay, so what this regular expression means is that we need a 1, 3, 2, 1 at the very beginning. That's a non-negotiable. And then next we can have any digit that's not 0 or 5. And then we can have any digit, and then we can have any digit that's not 5. And here we can have a 1 or a 2, any digit that's in between 3 and 6, 56, and here's any digit that's not 7 through 9, so basically 1 through 6, and 0 through 6. And then we must have an 8, and then we can have anything that's not 0, and then anything that's in between 2 and 6. So let's look. So this one, the string, it works so far. We have a 1 dash 3 2 1 dash. And then this one is not 0 or 5, so it works. This one is any digit, so it works. This one is not 5, so it works. And then we have something that's 1 or 2, which works. And then something in 3 to 6, and then something that's not 7 to 9, which works. And then 8, which works. And then we have something that's not 1. And the last digit is not in between 2 and 6, so it fails. So A fails. Okay. Next, we have 1, 3 2 1, which works, and we have something that's not 0 or 5, which works, any digit, and then we have a 5, but it specifically asks for something that's not 5, so then B will also fail. We don't need to check the rest of the expression because once part of it fails, the entire expression fails. Okay, next on to C. We have 1 3 2 1, which works, and then we have something that's not 0 or 5, any digit, and something that's not 5. And then we have a 1 or a 2, and then we have something that's in between 3 and 6, and then something that's not 7 to 9, and then we have 8. There's something that's not 0, and something that's in between 2 to 6, so C works. And then for the next expression, we have again 1 3 2 1, something that's not 0 or 5, any digit, something that's not 5, again 1 or 2, something that's in between 3 and 6, and then something that's not 7 to 9, and then 8, and then we have not 0, and then we have 4, which is in between 2 to 6. So D works. And then we have 1 3 2 1, and then we have 5, which is not not 0 or 5. This one clearly violates this expression, so this one fails. E fails. And then we have 1, 3, 2, 1, 3, which is not 0 or 5, any digit. And then 6, which is also not 5. And then we have a 1 or a 2 here. And then something that's 3 to 6, and then not 7 to 9. And then this is not 8. Wow, here in the expression it says we need it to be 8, so F also fails. So the only expressions accepted here are C and D. Okay, let's continue. Try this problem. Try this problem. So let's try this problem. So what this expression means is first we have anything that's not any number of things that are not G, K, or P. And then we must have a vowel. And we must have, or we can have 0 or 1 of and something that's in between A to E or L through T. And then we must have either S, ES, or ER. So let's look at the expression, like the strings, and see if they accept the expression. So for the first string, it's not accepted because we have a D, so it cannot be inside of this expression, so it might be inside the next expression, but we see that it's not a vowel, so it's not accepted. So then we have the next one, roses. Roses is R is not in between, not D, K, or P, which works. And then we have O, which is inside of A, E, I, O, or U. And then we have S that is in between L through T because S comes before T and after L. And then we have an ES, which is inside of this expression because we have either S, ES, or ER. So B works. And then let's check C. L is not DK or P. And then I is also not DK or P. So, well, for I, we could go to the next expression of A, E, I, or U, or say inside of here. But I realized ahead of time that the ES will be accepted by this part of the expression. And then we can have 0 or 1 of this one. So the I will be accepted by this part of the expression. So then we need the L, I, and L, the beginning L, I, and L to be in this part. So sometimes there are like multiple paths it could take, and we have to work backwards to find if it will be accepted or not. So the L, I, and L are going to go into this expression, and the I will go into here, which works, and then the E will be in this part of the expression, the 0 or 1, A through E or L through T. And then the ES will be in the last part. So Lily's works. And then we have D, Aster. So A is, again, we can look ahead. We want the E and the R to be here. And then we want the T to be the 0 or 1 question mark here. And then we want a vowel before it. But there's no vowel. So then D does not work. Because S is not inside of A, E, I, O, or U. And then next we have azaleas. So A and Z, we see a Z ahead here. So since Z doesn't go into the rest of the expression, we know Z must be here. So in turn, A must also be at the beginning part of the expression. So we have AZ go into the first part. And then there is an A. And then we also want the A and the L to go in the first part of the expression. Because again, we notice the S can be accepted here. And then we want an A to be the 0 or 1 of this one. And then we want the E to be the vowel here. So azaleas works because, again, working backwards, the S is accepted by the last one. The A is accepted by the one with the question mark of either 0 or 1 of A through E or L through T. And then the L, that would not work. Wait. Instead, we can go another pathway where the S accepted, oh yeah, the S is accepted by here. And then we have the A, which is accepted by the 0, 1, A through E or L through T. And then the E will be the vowel. And then the A, Z, A, and L are all not D, K, or P, so they can all be put into the first part of the expression. So azaleas does work. And then next we have irises, again, working backwards. The E and S will be accepted here. And then the S through T will be accepted into the 0 or 1, A through E or L through T. And then the I will be the vowel of A, E, I, O, or U. And the beginning I and R will be accepted into any number of not D, K, or P. So then F works. So next we have clover. And clover will be again, working backwards, E and R will be accepted into the last part of the expression. And then the V would not be accepted into this one. So we have to go ahead because it could work because we have 0 or 1 of A through E and L through T. And because V is not in this, we know that if it did work, it would be in the scenario that there is 0 of this one. So then we go back and see, will it work in A, E, I, O, or U? And it does not work, so G fails. And then next we have lilacs. So the S will go here in the expression. And C is in between A through E and L through T, so that works. It would be the 1 part of the question mark. And then we have an A, which is accepted by this part. And then L, I, and L are all not DK and P, so they would all go into this part of the expression. So H works, lilacs works. And then next we have violets, which is L. I mean, so then we know violets has to be the S out of in this expression. So working backwards, T would be the one in the question mark of that one. So we have T here. And then E will be the vowel here. And V, I, O, and L, again, are all not DK and P. So they can all go into this part of 0 or more not DK and P characters. So violets will also work. So in this expression, for this problem, B, C, E, and L are the different strings that pass this regular expression. So are there any questions about this? No? Okay. Well, it's 7:30 now, so that will be the end of class, and I hope that this was helpful to understanding FSAs and regular expressions. Thank you.